the United States should pay serious attention to China's recent findings on the Moon. If these reports are accurate, we might be on the brink of a monumental change, not just in space exploration, but in the way we view the future of energy and global power dynamics in space. For centuries, the Moon was thought to be a barren, unchanging rock, lifeless and cold. But recent breakthroughs from China's ambitious lunar missions are challenging everything we once believed about our nearest celestial neighbor. Specifically, China's Chang'e missions, including the U-22 rover, have uncovered astonishing new insights about the far side of the Moon, an area largely unexplored by other space agencies. These discoveries could reshape not only our understanding of the Moon itself, but also our place in the solar system, and possibly even impact the future of energy on Earth. In 2019, China's U-22 rover made a startling and unexpected discovery. While exploring the von Karaman crater on the Moon's far side, it encountered a mysterious, shiny, gel-like substance, something completely alien to previous lunar research. Researchers were initially confused. Could this be melted glass? Ancient volcanic material? Or was it something even stranger? After further investigation, scientists identified it as impact melt breccia, essentially glassy rock formed from the heat of meteoroid impacts. What made it particularly intriguing, however, was how new it looked. The region in question is considered geologically inactive, meaning the materials shouldn't have formed recently. This raised the question: what exactly is causing these phenomena? And could there be ongoing, unknown processes happening on the Moon that we are unaware of? But the gel-like substance was only the start. As the rover continued its journey, it made another groundbreaking discovery: large, translucent glass spheres scattered across the Moon's surface. These were not the small glass beads previously discovered by Apollo missions. These were sizable, ranging from 15 to 25 millimeters in diameter, and perfectly spherical. No one had ever encountered anything like them before. Researchers speculated that they might have been created by impacts or volcanic activity. However, there's a catch. The amount of energy needed to form these unusually large, symmetrical spheres is far beyond what typical impacts can generate. Furthermore, these spheres don't appear scattered randomly. They follow specific patterns, hinting at a possible underlying process that remains unknown. Could these be the result of unexplained lunar dynamics, or even some deeper geophysical forces at play beneath the surface? When scientists returned samples from the South Pole Aitken Basin, the Moon's largest and oldest impact crater, they were in for another surprise. The samples contained material never before seen in lunar samples. The South Pole Aitken Basin, which was formed over 4 billion years ago, is essentially a geological time capsule. Some scientists believe the impact was so intense it may have exposed the Moon's mantle, an area that's typically out of reach. When analyzed, the samples revealed minerals like olivine and orthopyroxene, minerals usually found deep within planetary bodies, including Earth's mantle. These materials hadn't been seen in samples from the Apollo missions. Even more puzzling, these minerals didn't fit with existing models of the Moon's composition, suggesting we may still have much to learn about the Moon's inner workings. Perhaps the most exciting discovery came when Chinese researchers identified a brand new mineral from their lunar samples. They named it Chang'e Site Y, the sixth new mineral ever found on the Moon. What sets this mineral apart is that it contains helium-3, a rare isotope that could revolutionize energy production on Earth. Helium-3 is nearly non-existent on Earth, but it's abundant on the Moon, where it's been embedded in lunar soil by the solar wind over billions of years. This isotope holds enormous potential for nuclear fusion, a clean and virtually limitless energy source. Scientists estimate that just 1 ton of helium-3 could generate more energy than 10 million tons of coal. The Moon could contain over 1 million tons of helium-3, enough to meet the Earth's energy needs for centuries. This discovery has thrust the Moon into the spotlight as a potential hub for the future of global energy. And the key question is, who will control this valuable resource? But the revelations don't end there. One of the most shocking discoveries is that water exists on the Moon in places previously thought to be completely dry. For years, scientists believed the Moon was devoid of water, making any future human presence on the moon seem nearly impossible. But recent data from the Chang'e 5 mission has confirmed the presence of water in lunar soil, even in regions that receive sunlight. Water molecules have been found inside tiny glass beads on the surface, and their concentration could reach up to 2,000 parts per million, small, but enough to sustain life. This water isn't merely surface contamination, but chemically bound within the glass beads, formed by impacts from micrometeoroids. In fact, there could be billions of tons of water in these beads, enough to support human life on the moon. Water could be used not only for drinking but also split into hydrogen and oxygen to fuel rockets or sustain lunar habitats. The geopolitical ramifications of these discoveries are immense. As China presses forward with its lunar ambitions, the United States finds itself in what some are calling the second space race. While NASA's Artemis program has encountered multiple delays and budget issues, China's space efforts are accelerating rapidly. China's goal is to establish a permanent presence on the moon by 2035, with plans to build a base near the lunar South Pole. If successful, China could control some of the moon's most crucial resources, water ice and helium-3. These resources would provide the foundation for sustained human life on the moon,